Not too much bothering about how much means. What happens is that suppose if you started, suppose if you go to water park where you have paid for something, so 1 hour, then when you are enjoying the ambience in the water park, at every moment of time there is a feel of regret. What is the feel of regret? That now within some time only it is going to end, and you always feel that no, time should not run, time should stop. But that is the case for close-ended sessions. But ours are open-ended sessions. So during any point of time, whenever you are finding that lecture very nice, the feeling that it is going to come to an end should be removed from you, from your end. Is it clear? You should remove the feeling from your mind that lecture is going to come to an end. It will not be coming to an end at all because it's an open time lecture. So, because what happens when in the water park, when you are there, then you are unable to enjoy because you are regretful. So such a combination of two complex phenomena disturbs you. What I would like to mean is that in the classroom you should not get that feeling. That since it's the very much enjoyable session, as if to exist forever, so that what we can say, regretfulness will not be in your mind. So with your minds being very much clear about the possible regret, we may start now. Yesterday we could not record few things. Because of that, we will not repeat, but we will just have a small session. So yesterday we tried to have analogy between water level model and electric circuit elements, electric circuits. So we had various equivalences. Those equivalences include, very simple, I did not write every time. First is water itself is equivalent to electric charge. Level of the water is equivalent to voltage. Flow of the water is equivalent to current. Tank is equivalent to capacitor. Valve is equivalent to resistor. Right? And for battery, even though pump is an example, is a good equivalent example, it has some limitations. Because of that, we have not considered this. The cameraman may use the other notebook. Do you have other notebook? Or you bring only one notebook? No, it's very unfortunate. So get a piece of paper from him, because it's not proper now to disturb the setup. Everybody should bring a separate notebook for my subject. So at least you must carry 2 notebooks. One for mine and what rest. See how resourceful he is. When a page was required, he has given only 1 page. Then, yesterday we had demonstrated 2 simple experiments connected to electric circuit and its water model equivalent. First was a simple constant voltage battery, a fixed resistance R, battery V, and a fixed current I. For that, the model was this. This is a tank, this is another tank. A constant field of water is made available over here so that the other problems will not come. So a level difference will always be maintained. So a level difference L. The valve opening is having some parameter. We can say for R, we will give some any parameter. Say O is for opening or resistance, and the water flow is F. Right? Level difference R, valve opening O, water flow F. So we will find that, or for valve opening actually may not be so much correct. We just give some closure or opposition. Okay, we say one opposition rather than opening is opposition equal to resistor. So level difference L, valve opposition O, and water flow F. So what we find? Less the opposition for same level, more flow. For same opposition, higher level difference, more flow. Is it clear now? This is very much simple. Then what we did, that we just repeated one experiment. It was a very interesting experiment, and I am sure that those who are sensible out of you must have definitely found out that this is one of the very classic, this V2 or VO. If I say V in, VO is equal to R2 upon R1 plus R2 into V in. Giving example of this here, this is somewhat simple. It has also its own requirements. Otherwise, what problem we overcome here? When you started thinking, you were using pump. Pump has its own demerits. To that we shall go later. Then you were using one tank. But when one tank was used, then tank level was changing. So our fundamental concept of a constant voltage, for that we need a constant level difference. That was not successful. So we using the municipal water flow, which is continuous, and letting this excess water out, also having a tap over here, we ensure that water difference is always maintained, water level difference always maintained. So a constant water level difference L between two levels, L2 minus or L1 minus L2. What is this battery voltage means? This voltage I am not sure what it is, but a battery voltage V means that point A is having at a higher potential by V volts than point B. It's a potential difference, VAB. It is VA minus VB. A battery of V volts only ensures that VA minus VB equal to V. Right? So this is a level difference. There is valve opening and flow. And because of this, flow meter is not required. We can measure this flow with the help of a measuring flask and a stopwatch. This was a good example. But to provide this, that this level is something in between these two levels, and by what extent it will be in between depends upon the ratio of these two, with R2 upon R2 plus R1. Right? So for that, I am sure that those few or maybe more, I don't know, you will compose of the class, who feel that, who are sensible enough, would have definitely appreciated it, and one or two students from your class only have found out the example answer, and we will find that the level will be somewhere in between. Right? So this is V1, V2. So this is difference L1 and this is difference L2, and this would be what? Proportional to which resistance? This resistance, or O2 we can say, upon this plus this resistance into this level difference. We need not see, it's an analogy model. We are you should understand the purpose. By systematically proving the complete mathematical relationship in water level model, we are not going to achieve anything. Water level model is just used to impress upon you the idea of equivalence. This is simple actually, this is not needed, but to give you the idea of capacitor, how things takes place, for that water level model is enough. Otherwise, since now you have advanced to second year of engineering, this is supposed to be well understood by you, or rather this is supposed to be well pseudo understood by you. Means pseudo understanding is that understanding wherein one feels that he has understood even if he has not. Are you getting me? Pseudo understanding is that state of mind of an individual where one feels that he has understood even though he has not. Right? We have got good pseudo understanding. So this was not that way needed. But once giving an equivalence, I am sure that you understood that these two are equivalent. Now we are going to have a very interesting example. And the example is very simple. Now there is a switch. In that there is a switch. A concept of switch can be there. On and off. Likewise, switch, what can be the equivalent voltage, equivalent term or equivalent device In water level model, what? Tag. No, how tag can be? Stopper. Right? It's a company switch is either off or on. Stopper means you can cut it or you can open it. Is it clear? Stopper. So we can use the stopper. And now I want that this is something I am sure that you are not exposed yourself to this. This was because this was told by me in the higher second, the class which is in third year now, last time second year, and looking at the degree of association of the seniors and juniors as regards to technical interaction, I am very much sure that none of you might have thought to try to know what is being taught, or none of the students from that class were curious enough that they wanted to share something which they have learned new. So this has ensured that you are unexposed to this phenomenon now. And in an unexposed state of mind, if you are able to answer the question, your work is in no way less important than that of a scientist, than that of a researcher. Are you getting me? What is the thing is that a new thing, a new is a relative concept. Something which you do not know, and if you are able to find out that, it's an invention. For your own satisfaction, its level is no smaller than an actual invention for the world. Therefore now, this is as it is, so what is flowing, it is coming out, it is having constant level. Then we may have a stopper S. The stopper S means it is tapped like off and on. So it has only two states, no middle stage, off and on. Stopper S, a valve V or opening a valve O, opposition, right? Means it can be adjusted with less resistance or more resistance. And then on the other side I am having a tank, but the only difference is that there is no opening for the tank now. There is no opening for the tank. Initially, in this case now, to measure the flow, what is needed? In this case, how will you measure the flow? How will you measure the flow in this case? You need a flow meter. You need an advanced device of flow meter that one can have. And in any case, I am again repeating that our elaboration is so detailed that nobody from your class will feel that this experiment is required to be done. I believe in class experimentation, in the sense that the experiment is elaborated to such an extent that everybody of you will definitely carry a feeling that whatever is elaborated in the experiment, actual experimentation, if performed, cannot be in any way different than what we have listened. It is very simple experimentation, and I am sure that you are sufficiently grown enough to understand that now there is no need for experimentation. Right? So we may have flow meter. So now we have, in earlier two experiments, tanks were not there. I again repeat, in earlier two experiments, tanks were not there. I had used tanks just because I wanted to maintain constant levels. I had used the tanks to maintain constant level difference only. Otherwise, they were not being used as tanks. These were used with openings, they were there. So just to create a constant level difference of L, I had used them. I am using the tank for the first time now. And when I am using the tank for the first time, I must get myself acquainted with the relationship which the tank provides for crucial parameters, that is quantity, level and flow. Quantity, level and flow. For quantity now, so in electrical engineering we are having charge. For the charge, it is taken as symbol is Q. Then we have voltage, and then we have current. and current is rate of change of flow of charge from a cross section. So similarly we are having level, we are having flow, we are having level, we are having flow, we have resistance, we are having opposition of the ball, and for charge it is Q. We may use something other than Q because there may be some confusion. So what we can use, we cannot use V because for volume V we can't use because it may confuse with this. It should be distinctly different. So let us use something, say X, just different for the sake of difference. So X is the quantity of water in liters. X is the quantity of water. It is on electrical side, it is on water side. The units are coulombs, volts, amperes. The units are liters. The unit is meters, and the unit is liters per second. Is it clear now? Just actually to be more scientific, I should have used meter cube, but I think we are not interested much in perfection, but in analogy. So I just use the word liters. Okay. Now I want the relationship for a tank between, when I say tank can have different shapes. A cylindrical tank, a rectangular tank. Right now we presume a tank whose base area doesn't change throughout its height, either cylindrical or rectangular or square, but its base area is uniform up till all the height. So now for such a tank, what is the relationship between different parameters? What would be the relationship between? So if a tank, forget about this tank being used here. Right now this is a tank. It is a tank. Then what would be the relationship between two basic parameters, X and L? X is equal to A into L. Agreed? X is equal to A into L. What is A? Area, base area. Is it clear? Relationship between X is equal to A into L. Now flow. When the tank is closed and flow will either come or go out. Suppose if there is a tap is here, then you can either pump the water from this inside, or you can have some water here, a stopper here. Now you open the stopper. What will happen? The water will flow out. The water will flow out. Now I want what would be the relationship of water flow F and water level L. Or if you don't want water level first, water flow and quantity. Water flow and quantity. Water flow and quantity. What would be the relationship?
Flow by time.
Flow F is equal to
X by T.
X into T. X upon T, right?
X by T.
So flow F is equal to X upon T. Herein we presume that there is simple error actually. Here is what we presume, that flow would be always constant, what we presume. A So in general, at any given point of time, what at any given point of time, the flow would be, what would be the relationship? Dx by dt. What dx, why, what do we get by dx by dt? That it indicates that it can be different at different times, right? Is it okay? So in general, the relationship is flow F, quantity x, and what is x actually? X is A into L. So we can have the relationship is F is equal to A into dl by dt. F is equal to A into dl by dt. In just introduction I have given. It is not very much in stricter mathematical sense, but I am sure that you have got something out of it, and definitely when that idea is clear, when we use it here, I am sure that everybody will understand how the things function. So let us forget about this now. Enough idea you have got. We are not interested to go into the stricter mathematical terms. Now, this tank is at this level, or the water level is here, stopper has closed the path, the other tank is having no water. So what is the water level here? Base level. No water means this level. And now, in this situation, if I open the stopper, water will start flowing. I want to know how what will start flowing. Means if a question is what will happen, water will start flowing and it will be coming into this tank. And what is the end state? Where the thing will stabilize? What is the end state? So it reaches up to this level, and that's all, right? But so if a simple question, what will happen when the tap is opened? This is going to happen, right? But now, if we try to detail out what you are having, flow meter, one may say, I have it, one may say that it is difficult to have, it's not that many rows, so I can do it alternatively. On this tank, this can be a transparent tank, and on this tank, there can be markings. And you can have a stopwatch. Then, suppose if, and it's a very large size so that you can take very comfortable. If it's very small, then you can't take comfortable readings. It is having sufficient large area also, sufficient large height also. Let us say it is having 1 meter height. 1 meter sufficient height. 1 meter height. So 1 meter complete marks are there with 100 centimeters, and you can read 1 millimeter. You can read up to a resolution of 1 millimeter. Or actually now you can take snapshots, so that right now the problem is that when I am taking reading, I may lose my concentration, so I misread. So you can record and then you can see. You can take snapshots at regular intervals. So I am having 100 centimeters, and in that again 10. So I am having 1000 millimeter is my length, 1 millimeter, 2 millimeter, 3 millimeter, and then I can take reading for every second. Means simply you can have it some programmable camera with which you can have a snapshot at 1 second each. You open the stopper and take 1 second snaps each. With this now, what would be the nature of level rise? You think for a while. Rate of flow will reduce, right? So he has answered very quickly. Maybe I should not have asked like this. I should have asked you to raise the hands. I should have asked you to write down. But I think it's very simple that everybody understands now that the water level in first second it may inch by 15 millimeters. In the second second it will be somewhat less. In the third second somewhat less. In the fourth second. Then if you try to plot a graph of the level risen versus the first second, second second, third second, what will the nature of the graph? It will be fast at the beginning, rise will be fast at the beginning and always slow, means at every instant it is slower than the previous instant. It is like this. Why it is like this now? How can you justify?
Level difference.
How can you justify now? What is the reason for this exponential nature of the graph? What will happen?
Level difference is decreasing.
What is now happening is that initially this was L1, this was L2 ground, so there was 1000 millimeter level difference was there. What is the cause for the water flow? Level difference is the cause. Level difference is the cause for the water flow. What is the effect of the water flow? Reduce the level rise of the tank, means reduction of the level difference. So cause is having an effect which is reducing the cause, reducing the impact of the cause. So can you now suppose if we say that there is a fixed opposition O, opposition is fixed opposition O. Initial difference is 1000. Initial difference is 1000. And we may say that O is having some units. If we are having a linear relationship between flow and level difference as determined by O. On electrical side, what relationship we have? I is proportional to V. And the relationship is I is equal to 1 upon R into V. I is equal to 1 upon R into V. Similarly, what would be flow? Flow F is equal to L upon O. Is it clear? Flow F is equal to L upon O. O is some constant. F is in liters per second. L is in, say, meters. 1 meter. 1000 millimeters need not take. Liters per second. L is in meters. For a given opening, so opposition will have is a constant of proportionality for this particular opening. Right? Is it clear? The relationship between, means don't take this, take previous example. Tank is having one level, other level, the levels are maintained constant, level difference maintained constant, opening is there, so there will be water flow. If you increase the level difference, flow will rise. If you reduce the level difference, flow will reduce. If you decrease the opposition, flow will increase. If you increase the opposition, flow will reduce. So there is a it's an assumption. If you ask the same question to a civil engineering hydraulics person, the answer may not be correct because there may not be exactly stricter linear relationship. But right now, for our all practical purposes, it is all right. So there is a linear relationship between water level and or level difference L and water flow F. Then now I want you to write down the equation between the water how this level means, for that we may use some other variable. Level in the output tank, LO, level in the output tank will change. Therefore I write LOT. LO, you got this? What is LOT? Because LO is not, when I use only LO, it has got a single value. It's not now. It will change as time progresses. Means now I want from you that if initially LOT is 0, or initially LO0 is 0, then if I open the stopper at t equal to 0, what would be the graph of LOT versus t? What would be the equation of LOT versus t? Laksha laga? Everybody understood what the problem is? We have a linear relationship between the flow and level, and the constant of proportionality is opposition. So flow is equal to level difference upon O. Here O is constant, that I am not changing in given set of experiment. Initially the level difference is 1, because this is 1 meter and this is 0. So L00 is 0. L00 is 0. Now, how we can write the relationship? So, what is flow? Flow is equal to level difference upon O. So, let us write down. I want everybody of you to understand this. So, flow F is equal to what? Level difference. Level difference. What is that? What is this level? 1. This level is 1, correct? It will always be 1. Again, flow I can write F. I have to write Ft. Why? Because flow will also change. Are you getting me? I am sure that you would be getting the difference between F and Ft. L0 and L0t. So Ft is equal to, it has to be what? Ft, see, since there is a linear relationship between the level difference and flow, so F is equal to L upon O, where F is the flow, L is the level difference, O is opposition. So O is fixed here, it is O, so in the denominator it will be O. What is the numerator now? Level difference. What is level difference?
L1 minus L2. L1 minus L2.
This level minus this level. What is this level? Right now 1 we have for simplicity, right? 1. What is this level?
2.
What is this? Not 0. L0t. This level is the level of the output. So 1 minus L0t. 1 minus L0t upon 2. Is it clear? So Ft is equal to 1 minus L0t upon O. Is one relationship. So what we know? We know O. Okay. But what we want to find? What is our aim? To find out L equation for L0t. But in this case it's not complete. So it's a complete now? Not complete. Why? Because this will give me, one will say, no, what is the problem? I can take O on the other side. L0t and bring it here. So L0t is equal to 1 minus O into Ft. L0t is equal to, so one will say 1 minus O into Ft. This is, my task is over now. It is just like if it is decided now that a German class is to start in the college, and we have one teacher who is able to teach German through French. Is it of any use to me? No, because I don't know French. What I want to know German from the language which I know. So I want to derive an equation for L0t, but it is unknown. So to express L0t in terms of ft is just like an attempt to learn German through French. This we don't want. We want to learn German through English. It's alright. So we should get rid of ft first. So this means one equation not enough. Now second equation. Second equation is very interesting equation. It's a tank now. It's a tank. And now what would be the relationship between L0t and ft? For tank, this is the equation not for tank. This is the equation for this O. The valve is a resistance, and the resistance keeps the current, which is equal to voltage difference upon itself. We use the property of valve or property of resistor. The equivalent circuit is like this. This is the equivalent circuit. C and R and the switch. So, what is VOT? VOT for resistor, this is 7 volt. This is 1 minus VOT upon R is the current. This current is determined by potential difference across resistor upon resistance. Also, current is determined by this voltage and relationship as regards to C now. So, if flow is Ft, what would be the relationship between Ft and L0t? This flow is considered as positive flow. Flow inside is positive. Level right is positive. What is the relationship for the tank? For the tank, what is the relationship between level and flow? What is the relationship between flow and quantity? Flow into time is quantity, or quantity upon time is flow. And what is quantity? Quantity is level into area. So I again try my level best. That what is A into L0t? What is A into L0t? Quantity of water at given point t, given time instant t. Then what would be flow? Quantity upon time. But when these are time variables, I can write an equation F as L upon O. But if I am not sure that these two terms will be constant, then what equation I write, if this time variable Ft, then it becomes O is constant, so it comes out, and d by dt of, so not here, actually it is O is df, it becomes dl by dy. Right now it's not material here, so you forget that. So flow Ft, we want flow Ft would be what? Can you write down now? Flow, and flow is coming in, level is increasing. So what would be, by what way the level will increase? Actually, I am trying you might be finding the pains which I am taking, but the pains which I am taking are deliberately being taken to avoid the word integration because it is somewhat difficult and derivative. Actually, level is equal to quantity is equal to flow into time, but since flow is not constant, it is integration of flow and time. It's integration of ft dt. Quantity x in the water tank is equal to flow into time, but it may not be constant. So if f is not constant, I can use f into t. So if f is not constant, then x becomes integration of ft dt. 0 to say time t. But I just don't want to use integration to that extent. Therefore, deliberately I am not using. I am at pains to not to use that term. So I use derivative is somewhat easily understood. So the flow F is equal to what? Quantity upon time. F is quantity upon time. So F is x upon t. What is x? A into L. So or L0 because I am using the word output time. So F is equal to A into L0 upon t. But since it may not be always constant, we have a more correct equation, that is Ft is equal to A is not going to change. A d by dt of L0t. I hope that you get something out of it. Ft, that is the flow is determined by this valve, level 1 minus level 2 upon a position. Also, this flow is to determine the level now, because this is the relationship between level difference and flow is the property of the valve, and relationship between flow and level is the property of the tank. And since we are having the combined element, both the things should be simultaneously satisfied. So I get Ft is equal to this. Ft is equal to A into d by dt of L0t. Then I can use what I don't want. My ultimate aim is to find out L0t. So Ft right now I am not interested. So I substitute this in this equation, and what I get now is 1 minus L0t upon O is equal to A into dL0t upon dt. So I can take it on the other side. So 1 minus L0t is equal to AO into dL0t by dt. I can take also this on the other side. So ultimately I get AO can be some other constant K. AO can be some other constant K. So K dL0t upon dt plus L0t is equal to 1. Or if you take minus 1 on the other side, it is equal to 0. So I get, so L0t, I do not get a simple equation L0t, but I get a differential equation of L0t versus time. And solution, then this differential equation should be satisfied for all. What should be the L0t function now? L0t function should be such function that it should satisfy the given differential equation at all the times. For all times t, it should satisfy this differential equation. So the solution for this differential equation is to be found out such that for all t's it must be satisfied. How do we find the solution then? How do you find solution to this difference? For simplicity, if this k is equal to 1, right? It need not be always, but for simplicity we take. For simplicity, this k is equal to 1. Then how will you solve the differential equation? Means AO, you have adjusted area and opposition such that the product becomes 1. So dl naught t upon dt plus L naught t is equal to 1. How to solve? You have learned differential equations. So how do we solve them? See, here we have developed the differential equation. You might have learned it otherwise also. Just taking differential equation without knowing its meaning is of no use. We have developed the differential equation now. And now we have to solve. How are we going to solve? Log of? What is the answer ultimately? Then now, the solution to this differential equation will have a constant term, constant of integration c. And that can be found out by it is equal solution for what? L0t. So it depends upon what was L00. What was level at time. You can also start with this close with some, we can pour some water in the tank. We can pour some water in the tank. That is what we can say initial level. So what is L00? So L00 is 0. If we assume that L0 is equal to 0, then we get a complete solution. What is the solution now? How to solve this? Forget about what techniques you know right now. I want L0 should be such function of time that at all times this is satisfied. So what you are doing? What are you doing? Hello. We are talking about differential equation. No, what is there in the bag? Why are you opening the bag? You look at the screen. It's there. Oh. So how to solve this now? What is the answer? How to solve this? I want L0t should be such that this differential equation is satisfied. For given equation, for given relationships, we can find differential equations. But its reverse is not so easy. Say for example, what is the differential equation? Say for example, if I take xt equal to sin t, xt equal to sin t is the equation. Xt is sin t. Then this gives rise to a differential equation. How does it give rise to differential equation? You go on differentiating till, okay, forget about this. Let us consider this because both are important. Xt is equal to sin t is an equation, right? It's a function. So construct a differential equation for this function. How will you construct?
dx by dt equals.
You differentiate. What is dx by dt? Dxt by dt is cos t. Correct? Then still I don't get much thing, but I further differentiate. So d2xt by dt square is equal to what? Is minus sin t. what it is? It is xt itself. So d2xt upon dt square is minus xt. That I can take on the other side. Then this becomes not equal to d2xt upon dt square plus xt is equal to 0. Is my differential equation. But from this, how will you go for solution? So from a function arriving at a differential equation is alright. From differential equation, how do we arrive at the solution? And the function. It's a second order, it's a first order. It's a first order function. So how do we solve? What? What should be the approach? We are stuck out. We should come out. We should move out. How will you solve this? Yeah.
So should I say the answer?
So yeah.
So L0 of t is equal to 1 plus constant into e power minus t by
E by?
e power minus t by a.
No, everything you forget now because that none of them is appearing here. AO is coming. AO is 1. So L0t is equal to
1 plus constant into e power minus t
1 plus constant to e power
minus t.
minus t. That's all. 1 plus C1, right? Is it okay? But why you have kept C1?
Constant of integration.
But that you have to remove
L0 of 0 equal to
0.
0.
So what is the constant now?
Minus 1.
Minus 1, right? So you are very perfect. Let us applaud him for a very good answer. L0 is equal to 1 minus e raised to minus t. A0t is equal to 1 minus e raised to minus t. Is 1 plus c1 e raised to minus t is correct. But since L00 is equal to 0, at t equal to 0, c1 becomes minus 1. So L0t is equal to 1 minus e raised to minus t is the answer. How to arrive at now? Can you explain?
So first to find integrating factor out of linear differential equation. If the solution is given by
So you are a very classical student. So very good, but that approach may not serve many. So how would we proceed then? A differential equation is to be solved. What should be the approach? It's a simple one. How do we solve now? Let us say we have one equation, simple one, dl0t upon dt. dl0t upon dt is t for time being. How we have solved it? Why this is simple to solve? Because it is separable variable. What do? dt take on the other side. So we get dl0t is equal to t dt. Integrating both sides, we get dl0t gets integrated to l0t. Integration t dt. That is l0t is equal to t square by 2 plus c. So if it's separable variable, we integrate instantly. But if it is not separable variable, then there are some pains to be taken. So here what do we do now? Put a what? Okay, but putting L0t on right side, it doesn't serve the purpose. Why? If I put L0t on the right side, it doesn't become separable variable. It doesn't become separable. So, the classical fellow, can you elaborate in such a non-classical way so that a person should understand what he's doing?
In this case, we use second order derivative is equal to minus of xt.
Yeah.
And in that case, there is first order derivative equal to L0t minus 1. So we use exponential.
So what do we do? So we so these are some techniques now. See, there are different ways of arriving at a problem. First is to be able, a perfect classical thing is that you should be able to derive without assuming. Then what he has stated that for this type of, since there is a first derivative, the variable itself and a constant. First derivative, a variable itself and a constant. What is the type of solution we expect? Exponential. When it's exponential, what would be there? E would be there. T would be there as an exponent to E, and what would be there? Some constant would be there. So, what is the typical solution? What is the typical solution? So, we may presume a typical solution, and presuming this to be a typical solution, we may proceed further. What is the typical solution then? That's what he has suggested. So, what he is saying now is that this type of differential equation can only be satisfied by a typical set of solutions. Just a minute. So the typical solution is L naught T is equal to C1 plus C2 e raised to why minus T only? Why not minus C3T? Or why minus only? Why minus? I can say K1T. L0T is equal to C1 plus C2 e raised to K1T is a general solution. Right? Now, one of the issues gets immediately solved. What is that? So once, see, whether this presumption is correct or not, to that we shall come later. But as he has suggested that since we go with some presumptions, for this means his presumption is that, not his actually, it's a classical presumption, is that such kinds of equations have got exponential solutions. So this is a general solution. Now, it becomes very immediate possibility to get rid of few constants. How? One is, what is L00? L00 is 0. So when L00 is 0, 0 must be equal to what? C1 plus, at t equal to 0 it becomes 1. So C2. So C2 is equal to minus C1. So I can get rid of C1 into bracket 1 minus K1 e raised to K1. Nice. Is it correct now? C1 into bracket 1 minus e raised to K1. Then now how to proceed further? How to proceed further? We are solving by brute force method.